This is just a short introduction to the normal distribution. So we've already seen how data sets can follow different shape distributions. They can follow distributions that are skewed left, skewed right, normal, bimodal, unimodal, several different shapes to a distribution. Now some distributions are normally distributed when we have the population's data. So we know that height of our entire population is normally distributed because we have a lot of people around the mean. And then we have less tall people and less short people, but generally we have around the same percent of tallies as we do shorties. So height is a data set that we know follows a normal distribution. In addition, GPAs, or student performance, also follows a normal distribution, where oftentimes we have a lot of students performing around average and then a small percent performing in the top average, and then a similar percent falling below average. And shoe size, in this case we'll do female shoe size, also follows a normal distribution where a lot of people or females are wearing the average shoe size, and then less wearing really big sizes or really small sizes. Now ideally, if we notice that something follows a normal distribution, we can in a sense just use a sketch of the curve that models the normal distribution rather than having to focus on all the bars, because we know it follows a trend where most of the data is piled up in the middle. And this is actually around the mean, since we do know already that in a normal distribution the mean, median, and mode will all be lined up in the center. And what happens here on a normal distribution is we can actually use standard deviations to see approximately what percent of data lies within two values. So if we're talking about birth weight here of babies, then we can kind of estimate where the average birth weight is, and then we can use the standard deviation, remember, which is the distance on average data points are from the mean, but we can use a standard deviation to do some further analysis. So to use the standard deviation to further analyze the situation that can be modeled on a normal distribution, we have to talk about the empirical rule. So the empirical rule is a well-known rule in the world of statistics that gives us an estimate of what percent of the data we expect to lie within one standard deviation of the mean. So here, let's go ahead and change my little pen size so it's not so thick. Okay, so here we know that the mean is in the middle. So the mean is 0 standard deviations away from itself because it's no distance from itself. Now if we go out 1 standard deviation to the left or to the right of the mean, the empirical rule tells us that we can expect 68% of our data to lie within 1 standard deviation to the left and right of our mean. So 68% of the data we expect to be right there in the middle within 1 standard deviation, left or right of the mean. Now the empirical also says if we go out 2 standard deviations of the mean, left and right, we can expect, and I'm going to draw my lines up here, 95% of our data to land within there. And that is why we have that quick rule for estimating outliers, because really if we expect that there's going to be 95% of our data within 2 standard deviations left and right of the mean, then yeah, this stuff over here and over here, or these data points, I shouldn't say stuff, but these data points over here and that land over here are very abnormal. They're not usual. So there's a very small percentage of data points on the left and the right of those cutoffs there. And that's kind of why we use that quick way to estimate whether or not something is the outlier, by seeing if it's more than 2 standard deviations out from the mean. But just continuing on, so within 3 standard deviations of the mean, that's all our standard deviations there, but within 3, we actually are expecting approximately 99.7%. Now that is really almost all our data to lie within 3 standard deviations of the mean. So that's what the empirical rule tells us. It basically tells us on average what percent of the data do we expect to land within certain standard deviations of the mean. Now, if we broke the empirical rule down further, this is actually a little bit more helpful. Notice it is still 68% within one standard deviation to the left and right of the mean. It's just that if we break it down into two different sections, we can actually see, okay, what percent of the scores do we expect to land between the mean and one standard deviation higher, or vice versa, one standard deviation lower. Now, we still are seeing 95% of the data, but once again, these are just more broken down. The sections are more broken down to where the sum of these four is 95%. So I'm showing this because some students remember the empirical rule. Yes, you can. That's three numbers, three percentages. It's going to be the same percentages you use for every data set that models, that could be modeled with a normal distribution. But if you remember these four numbers here, it's actually going to allow you to get to answers or understand the percentages you should be getting a little bit better because they're more broken down. So for instance, let me erase all of my ink. But for instance, if I asked what percent of the data can we expect to lie below 2 standard deviations of the mean? Well, we know that the mean here, you should expect 50% over here. So I don't even need to add this much because the middle line, of course, is the mean and the median and the mode. So we expect 50% of the data to be over here. So I can then just add up these onto my 50%, and that'll tell me approximately what percent of data do I expect to lie below 2 standard deviations from the mean. So it's just a little bit quicker than having to break down the percentages each time. All right, so now the last thing I'm going to mention before you get into how to actually calculate in a different video using the normal distribution curve, I just want to mention a z-score is the amount of standard deviations a data point lies above or below the mean. So if someone scored on a test 1 standard deviation above the mean, I know that if I think about those percentages again, that they are, if they scored 1 standard deviation above the mean, then I know that, yes, they scored better than this 50%, but they also scored better than this 34%. If I just go back here, that's that 34%, 1 standard deviation above the mean. So altogether, if their test score was 1 standard deviation above the mean, I know they scored better than 84% of students. So their z-score equals 1, their percentile. So we didn't really get into that word yet, but this is exactly what it is. A percentile is the percent of individuals or data points that lies at or below the data point that we're interested in. So if we know a student scored 1 standard deviation above the mean, that means that their percentile is at 84%. So they scored better than or equal to 84% of other students.